We were talking about transformations of quadratic functions, and you want to graph quadratic functions in standard form and determine whether a graph has a minimum value or a maximum value from the given a value. So minimum or maximum right now, we can look at this and we're going to say that we have a is equal to -2. So that means that our graph is going to open like this. So we're going to look that we're definitely going to have a max value. Before we can figure out exactly what the max value is, we need to calculate our line of symmetry. So our line of symmetry is going to be x is equal to, we got to always have the negative, we always got to have the divide, and we always got to have 2. The thing that changes is we have our a in the denominator and we have our b in the numerator. So we can substitute our values in, and in this case, we're going to get x equals negative. And if we look up here, we already said our a value was -2. Our c value is 4. And our b value is not there. There's no x term. So because there's no x term, our b value is equal to 0. So we substitute in -0 divided by 2, and then our a value is -2. Now, what's in the denominator doesn't matter in this case because we have 0 in the numerator, so we get x is equal to 0. So that goes in for our vertex. So for our vertex, we know that the x value is going to be 0. And that comes from our line of symmetry. Now, in order to figure out what the y value is, we have to substitute 0 into the equation. So we're going to calculate h of 0 is equal to -2 times 0 squared plus 4. So we're going to substitute 0 in and see what we get. So 0 squared is 0 times -2 is 0 and plus 4. So then we get the function h evaluated at 0 is equal to 4. So that is our y value of the vertex. So we know that we're going to open down, and we know that our vertex is at 0, 4. So put -5 here, 5 there, 5 there, and -5 there. And then we're going to have the point 0, 4 as our vertex. And this is actually as our y-intercept comes from our c value, which we said c is equal to 4. And so our y-intercept is 0, 4. So our vertex and our y-intercept happen to be the same thing. Now we can substitute 1 in and figure out what happens, and we can substitute 2 and figure out what happens, and then we can graph it. But what I like to do is I like to take the parent function and just scale the parent function. So the parent function has an a value that is equal to 1. And so the parent function says if you go over 1, then you go in the y direction, you go up 1. And if you go over 2, then in the y direction, you go up 4. Now, For this function, we're going to scale it by a factor of -2. So we're going to take whatever the y direction was, and we're going to multiply by -2. And then we're going to multiply by -2. And so instead of going up 1, I'm going to go down 2. Instead of going up 4, I'm going to go down 8. So we're going to put this line over 2, down 8, over 1, down 2, and then we'll have our graph. So go over 1, down 2, over 2, down 8. So 4, 5, 6, 7, 8. Now, the line of symmetry, or the axis of symmetry, we already calculated was x equals 0, so we can flip or reflect the points over the y-axis. So this one's over 2 this way, so we go 2 that way. This one's over 1 this way, so we go 1 that way. And then we can finish. So we got a lot going on there. Now we're looking at our domain. Our domain for this is always the same for parabolas. This arrow here has 2 directions that go with it. It has a direction that goes in the x direction and a direction that goes in the y direction. So this arrow means in the x direction, it goes to -infinity. And this arrow means in the y direction, it goes to -infinity. Here is the same thing, except for as we go to the right, we're going to +infinity. And as we go down in the y direction, we go to -infinity. So what part of those represent the domain? Just the x. So we're going from -infinity over to +infinity. So in the domain, we go from -infinity to +infinity, and we can never count that high, so we can't include them. So those are parentheses. The range is our y values. So maybe we put that down. These are the x values. The range are all the y values represented by the graph. And so here, we always start from low, right? We start from low, go to high. Same thing, we're going to start from low and go to high. So what's the lowest? We go to -infinity and -infinity. That's the y. So we're going to start at -infinity. And then we're going to see how high do we go. We have a maximum value where y is equal to +4. So +4 is included, so we use a bracket there, and this represents all the y values. Then the last part we have is decreasing and increasing. As we read the graph, just like paper, we read it left to right. So we go from the left, and as we come into contact with the parabola, what happens to our pen tip? It increases. So this is going to be increasing. So in the domain over here, just the x values, we start here and we work from -infinity, and we're increasing all the way until we get to 0. So this is increasing, and this just refers to the x values. Just the x values for increasing and decreasing. So we're increasing from -infinity all the way to 0. Now, in this case, neither one's included because can't count to -infinity, so we'll have a parenthesis there. And 0 is not included because we actually have a slope of 0 at the vertex, which is neither increasing nor decreasing. So 0 is also not included. Now, decreasing, it will start up immediately at 0, and then it will go all the way to +infinity because it's going to decrease and keep going and keep decreasing. So that goes to positive infinity. We don't include 0 because that has a slope of 0, and we don't include positive infinity because we can never count that high.